Hey everyone, welcome back. In this video, we are going to see statistics that is required for data science. So first, I will explain the concept. Then we will see the practical implementation of those concepts. Then I'm also going to explain an interview question. So now let's dive into the video. So this is the data set I'm going to use to explain the concepts. So first we are going to see mean. So the mean can be calculated by summing all the values in the data set, right? We have to sum all the values and we need to divide by the number of values present in the data set. So in this case, if we add all the values in the data set, I'm going to get 108 and we have 10 values and we need to divide by 10 and I will be getting 10.8, right? So now we will see median. So to calculate median, we need to sort the input array, that is the data set, in ascending order, right? So this particular data set is already sorted. So we need to sort it. Then we need to pick the middle value in the data, right? So in this case, since there are even number of values, we will end up having two values in the middle, right? So when we have two values, we just need to add these two values. We will be getting 22, right? 10 plus 12 is 22 and we need to divide by 2. We will be having 11. So 11 is the median of this data. So the reason why we are learning these basic statistics is that I will show you guys in the end of this video when I explain the interview question. So in that particular concept, you would know how effective these particular concepts are, right? So next we will see mode. So to calculate mode, so we need to check the high frequency values, right? We need to check the high frequency values. That is the repeated values, right? So here we could see 2 has appeared twice. So 2 is the mode. So what if we have 2, 6 here? In this case, we will pick the two values as mode. This is called bimodal, right? This is called bimodal. When you have two modes, it is called bimodal. Next, we will see percentile, which is another interesting concept. So to calculate percentile, first we need to sort the data. Since the data is already sorted, I'm not sorting the data here. Now assume we need to find the 25th percentile, right? So to calculate 25th percentile, I need to divide 25 by 100 and then I need to multiply with the number of values in the data, which is nothing but 10 plus 1, right? So if I calculate this, I'm going to get 2.75. So this 2.75 is the index in my data set. So this is my first index and second index, and this is my third index. So 2.75 index is between 2 and 6. So in this case, we need to take average between 2 and 6, right? So we are going to have 4. So 2 plus 6, we are going to get 8. Divide by 2, we are going to have 4. So 4 is the 25th percentile of the data set. So in other words, I can say that 25% of values of the data set are less than equal to 4, right? Which is these two 2's are 25% values of the data set. So now assume we need to calculate for 75th percentile. So we are just changing the value alone here. So here I'm going to get 8.25, right? So I need to check the 8.25 index. So this is the 8th index and this is the 9th index. So it is in between these two values, right? 8.25 is in between these two values. So I need to take average between these two values where I will be having 34 if I sum them, and I need to divide by 2 and I will be getting 17. So there are 75% of values that is less than or equal to 17, right? So now we are going to calculate interquantile range. So to calculate interquantile range, we need to take the 25th and 75th percentile. So the 25th percentile has been represented using Q1 and 75th percentile has been represented using Q3, right? So here we have taken 4 and 17, which we previously calculated, right? So the formula for interquantile range is nothing but Q3 minus Q1, where we are going to have 13, right? So 13 is the IQR, that is the interquantile range. So why we are doing all these calculations? I will show you guys in few minutes. So using these three values, we are going to remove the outliers in the data. So outliers are the points that is irrelevant to the data, which is nothing but written by mistake. So if you give those data to the model, we are going to have a lot of inaccuracies, right? So the machine learning model will not work properly. Just you can assume like that, okay? So now using these three values, we are going to calculate upper bound and lower bound, right? So to calculate the lower bound, we need to take difference between Q1 and we need to multiply 1.5 with IQR, that is the interquantile range, right? So if I just substitute the values here, 4, 1.5, and we need to multiply 13, that is the IQR. So we are going to have negative 15.5, right? So to calculate the upper bound, we need to add Q3 and we need to multiply 1.5 with IQR. So if we substitute the values and calculate, we are going to have 36.5, right? So assume if there is a point like minus 100 and 100 in this data set, right? So since we know this is the range of normal values for this particular data, whatever values that falls out of this range will be considered as outliers. So in this case, negative 100 and positive 100 are the outliers, which is an extreme value. Assume if we consider these values in the data, we are going to have a high impact of these values and the model is going to perform badly, right? Just look at the data. These two values, the negative 100 and positive 100, looks very odd, whereas other values looks very normal, like the difference between them is 1 or it's very less, right, compared to negative 100 and 100. So that is called outliers. So next we will see an interesting interview question that has been asked by two companies, two very good companies, where I actually got a chance to interview with them. So now let's see that. So the question is, why median is better than mean? So here I have the very simple data. Just pause the video and just think why median is better than mean here. If you guys found yourself, well done. So now we will see the solution. So first we will calculate mean here, right? So we need to sum all the values in the data, where I'm going to get 109, and we need to divide by the number of values in the data, which is 4. So I'm going to get 27.25, right? So we will keep this aside. So to calculate median, first we need to sort the data. So we're going to have 2, 3, 4, and 100. We need to pick the middle value. So since we have even number of values, we will pick the two middle values. We need to add these two. We are going to get 7. We need to divide by 2. We will be having 3.5, right? So median is 3.5. Can you see the difference here between mean and median? The mean is very large compared to median, right? The reason why mean is very large is we have a larger value in the data, that is 100, and this 100 can be an outlier. So basically outlier is a point which has been entered due to a mistake, right? So this 100 is impacting mean. That is the reason mean is very high. So assume we need to avoid all the values that is less than 27. So if I do that, I'm going to avoid many useful values, right? Just because only one value, I'm going to avoid a lot of useful values. See other values, 2, 3, 4 are just normal. They are just the same. So if I'm going to reject all the values 2, 3, and 4, which can be useful. In other words, we can say like other values are very similar. They have a difference of 1, right, between each other. But there is only one value which is looking like an out of range value, which is nothing but an outlier, right? And this one impacts mean. Whereas if you look at the median, it is not impacted. It is somewhere between the normal values 3.5. The reason is that when we sort the data, the extreme outlier will end up moving to the last, right? And we are just picking the middle value. So in this way, we are going to avoid outliers. That is the reason why median is better than mean, right? So that is the way to answer this particular question. So now we will see the practical implementation of all these concepts. So before we see the practical implementation, if you guys haven't subscribed to my channel, please like and subscribe. This will motivate me to upload more videos in future, and also check out my previous videos and keep supporting, guys. So here we are using a NumPy library, and we are importing that one, and we are naming it as an NP. And also we are importing stats from the SciPy library. So then we are having the data that we used. Then we are converting it to the NumPy array. So simply assume, as of right now, we are just converting NumPy array in order to apply the statistical functions in the library, right? Then here we are just calculating the mean of the data, where we can use mean function from the NumPy. Next, we can calculate median using the median function from the NumPy library. Then we are calculating mode using the stats library from the SciPy module. Then for calculating the percentiles, so in the percentile function in the NumPy library, first we need to mention the data. Then we need to specify the value, that is which percentile of value you need. So we are calculating the 25th percentile, same for 75th percentile. Then finally, we are calculating the Inter Quantile Range, IQR, where we are taking difference between the 75th and 25th percentile, Q3 and Q1, right? Thank you guys for watching this video. Please like, share, and subscribe. This will motivate me to upload more videos in future. And also don't forget to press the bell icon so that you will get the notifications whenever I upload the video. And if you guys have any kinds of doubts or any feedback, put that in the comment section. I'll see you guys in the next one. Cheers, guys.